Hello friends, welcome to Learners Forum. So this video is about the next type of code, which is gray code. So once after seeing about all the characteristic feature, let us justify each of the points also. So this gray code is also called as reflected binary code, unit distance code, cyclic code, or minimum error code. So this particular gray code has two consecutive values that differ by one bit only. And to reduce switching, we are converting binary into gray code. Now let us see the conversion of how to convert from binary to gray code in detail now. So to convert binary to gray code, let us take a binary bit which is B3, B2, B1 and B0, and the equivalent gray value, let it be G3, G2, G1 and G0. So how to obtain the value of G3, G2, G1, G0 from the given binary number is the procedure. So the first bit B3 is always taken for G3, that is going to remain the same. Next for G2, we have to take B3 and B2 and perform XOR operation between them. So we have to XOR B3 and B2 to get the value of G2. That is why the arrow mark is given in this particular manner. Next, to obtain the value of G1, again the previous value B2 and the similar value B1. So B2 and B1 has to be performing XOR operation to get G1, and for G0 again past and present B1 B0 XOR value will give the value for G0. So in expression wise we can write it as G3 is equal to B3 since we are doing it same way. Next, for G2, now we have to consider the same bit and the previous bit. So B3 and B2. So B2 XOR B3 we will give the value of G2. For G1 it is B1 XOR B2. Next for G0 it is B0 XOR B1. So this is how we have to convert the given binary code B through B. For example, if it is 0, 1, 1, 0. Now let us write the equivalent gray code using the conversion formula now. So the same value is maintained for G3. So it will be 0 since B3 value is also 0. Next, to get the G2 value, we have to XOR B3 and B2. So for XOR operation, the truth table is when we have the same value, the output will be 0, and for different value, the output will be 1. So following this particular technique, we can use it over here. So when B3 and B2 are different, the output will be 1. So G2 value is 1. Next, to get the value of G1, we have to take B2 and B1. They are same value. So output will be 0. Next, to get G0, B1, B0, the values are different. So the value output will be 1. So for 0, 1, 1, 0, which is the binary code, the equivalent gray code will be 0, 1, 0, 1. So this is how we have to convert a given binary code into gray code. Next, let us see conversion from gray to binary. This is opposite case. So the gray value is represented as G3, G2, G1 and G0, and the binary value is represented as B3, B2, B1 and B0. Now let us see how to convert this gray value into binary. So the first value G3 is same for B3 also, like in the previous case. But next, to obtain the value of B2, now we have to consider the value of B3 and G2. So one bit of binary and one bit of gray value has to be considered, and we have to perform XOR operation to get B2 value. So in previous case it was like both the nearby values, but here it is one bit binary and one bit of gray to perform XOR operation. So that is why we can track by means of this arrow mark. To get the value of B1, the previous value of binary is B2, so we have to take B2 and the corresponding gray value is G1. So we have to XOR B2 and G1 to get the value of B1. Next, for B0, again we have to consider previous bit of binary B1 and the same value gray G0. We'll get the value of B0, and expressing it now, B3 is equal to G3 since both are same. Next, for B2, we have to consider the previous binary bit which is B3 and the same gray bit, so G2. B3 and G2 has to be XOR. For B1 it is B2 XOR G1, and for B0 it is B1 XOR G0. So these are the expressions to convert a given gray code into its equivalent binary code. Now we can fill the table where it has decimal, binary and gray value. For 0, the binary value is 4 zeros and the equivalent gray value is also 4 zeros. Next, for 1, Using the binary to gray conversion code, we can convert the equivalent values of decimal to binary, and from binary we can convert it into its equivalent gray value. Now we can check all the values, and we have seen about a statement also where the gray bit differs by only one bit. The switching rate is minimum whenever we use gray code. For example, if we consider the first two bits, all the three bits are 0 and only the last bit is getting differed by 0 and 1. So we will have only one switching over here. It is not just for these two bits. If you consider any number of bits, we will have the same switching. For example, if you consider 5 and 6, again first bit, second bit, only the third bit is getting differed, again the fourth bit remains the same. So there is only one switching whenever you consider for any consecutive two decimal values or the equivalent gray code values. So this is the reason we are using gray code, because the switching rate will be very minimum over here. So for 3 and 4, if you consider, the binary value is 00 and 01, 1010. So 3 bits are getting differed here. So the switching rate will be very high when we consider the binary for 3 and 4. Whereas in gray, we will have the first bit remains the same, second bit it differs, third bit same, and fourth bit is also same. So we will have just only one switching over here from 0 to 1. So in binary we had nearly 3 switching, whereas in gray we had only one switching. So the rate will be minimum in case of gray code. This is the most advantageous feature of this particular type of code.